So after we created the schematic for this resistor 0402, let's do in this video the layout. And we have two methods we can use to create the layout. I will start in this video from the first method. So first, file, new, and then library. We keep it on the local, and then we create a PCB library. So here you can see it's the same overview of the schematic. So now we have created resistor 0402, and here we need to create also resistor 0402. So I will just save it. So I save it on the same library I used, the same folder. Then I give it the same name and then save. Now we go to tools, IPC compliant footprint wizard. Then next, then we need to choose this one here. So it's for capacitor, inductor, resistors. Then next. So here we have to provide all the numbers, and this is coming from the data sheet. I will also upload this data sheet. Just to see the data sheet. So it's this data sheet for all resistors. And if we go down, close this. Here we have for all type of resistors. So what we're looking here is 0402. So we have to put this number over here. So that's basically what I did before. So just Altium save it. So I have the length L. It's 1 plus minus 0.05. So I put 0.95 and 1.05. The body is the same I did. So which is the W, sorry, here. And I took these numbers from the W. And then the bandwidth T, which is I1 plus minus 0.1. So I just put all these numbers. And then you do generate step module view. So it will generate a 3D module for you. Then here the package we need resistor. So we keep a resistor. Then next. So this is just Altium start to calculate this S parameter. We keep it the same. The density level, I keep it level B. If you want really low density, you can put it level A. Then it will be not a lot of spacing to solder your components, especially if you do it by hand. And if you notice in the data sheet, this is for reflow. This is for reflow oven, but still work with hand soldering. So then next, we keep everything the same. Next, use default values. So here it will show me the X, how much it will be, and the Y, it will be 0.55, which is the average of what we saw in the data sheet. And then the spacing between the paths is 0.9. Then next, the silk screen, so around the module, it will be 0.2, the distance between the batt and the silk screen layer. I keep it the same. Then I keep those the same. And here, suggest, and I call it the resistor 0402. Next, here it asks me where to save it. So I have saved it on the same schematic library as well. And then next and finish. So now Altium created my layout in a simple, fast way. We can check the parameter. So X is 0.55, Y is 0.55. Then the shape of our pad is rectangle. We keep it rectangle. So the thing I want to change here is this solder. So solder mask expression. And this you can take from your manufacturer. So in GLC PCB, they say this for 2 layers is 0.038, and they suggest to keep it at least 0.05. So I will set it up for 2 layers. You can see here a multi-layer is not required. But in case I want to use the same resistor, if I'm working in 2 layers, then it will work as well. So I will put this value here. I go here, manual. Then I change it here as well, manual. So after that, I go, so you can see here, it already created resistor 0402. I go to view configuration to change some stuff. So if you cannot see it, you can go to panel and then click on this view configuration, then it will be showing up. So first I will add some layers. I will start from assembly layer. Assembly layer is not something your manufacturer needs, or it will not be shown when you when you order your PCB. It's just for documentation. Manufacturer assembly layer basically shows the exact outline and details for your resistor. So basically if I click 3, so it will show the exact size of my resistor. So this edge from here to here to here to here. So here we can see also when we press 3 how it looks, our resistor. So we have a nice spacing here. We have a nice spacing here to solder. Here we don't have a lot of space. You can see it's exactly on the edge. So what I like to do also, I like to change it to 0.6. Sorry, the x-axis 0.6, then 0.6. Then if I go to 3D, so now it's easier also if I want to place it manually. It's easier for me to place it manually when I have a little bit spacing here. That's something you can do. Remember Control S. So let's back to the assembly layer. So I right click here. Oh, sorry. Let me back here. Close this. Right click here. Add components layer pair. Then I have to look for assembly. And then OK. So now I added assembly layer. We can see here clearly. So this is the assembly layer, which correspond with the body of the resistor. So I go to mechanical 13, then shift S to just make it visible. Then I press this, and then I press shift, press this, and this. Then I change it and I send it to the the layer I just create, top assembly, which is here. I can change the color just to not be confused between two layers. So if I go to tab assembly, that's exactly what we explained, which is assembly layer. And if you cannot see this, you just simply draw a simple rectangle that match the actual resistor body size. And as I said, it will not affect anything in your PCB manufacturer files or your actual PCB. It's just for documentation. Then I will add another layer, which is the 3D body, and then OK. So you can see this is basically the 3D body. So if I remove it and then press 3, so then you cannot see any 3D body. I will just Control Z, and now you can see the 3D body. So we notice also it's in the mechanical 13, which is not nice. So if you're making the layout and you want to see if all your components have a 3D body, then you create this 3D body layers. Then you can select the 3D body layers and see if all your components have 3D body. So I will move this to top 3D body and then Control S. So now it disappeared from mechanical 13. So basically mechanical 13 is empty. But if I select top 3D body, which is I have Control S and here top 3D body, then it will be on the top 3D body layer. So I don't really need this layer anymore as well. So it's here the top 3D body. So Shift S, then we can see our 3D body. Now the top over layer. So the top over layer is what you actually see in your printed PCB. So when you manufacture your PCB, you can see it as a white drawing. And this is basically is this sample outline for your component. So the outline of my resistor. So if I go to top over layer and then Shift S, I can see I don't have any top over layer. For resistor, I don't really want it, but some people they like to show it, especially in if you're making a develop board. Then you can see how you place your resistor, and then it has an outline here. But let's learn how to do this top over layer. So I can use this actually as a layer because it will work with top over layer. So I want to reuse it. If I press here, I can see it's mechanical 15. Then I go to mechanical 15, Shift S twice. Then I select this, I press Tab, then Control C. And then when you write Control C, you can see this showing up. So you bring it to the middle and then left click. And then you go to top over layer and then edit, paste special, and then paste on the current layer. And then Control S to save. So I press Shift S again. Now you can see if I select the top over layer, it will show like this. And the 3D module, it shows over here. Go back to the 2D. You can also bring it a little bit closer. But the only thing when you're doing that, You have to check your manufacturer how close your silk screen layer it should be from the actual pad. So let me put it back. So if it's 0.2, then the distance between here and here should be 0.2, and as you see in your manufacturer. Now I will add another layer, which call it Courtyard here. So Courtyard layer, and then okay. So let's show immediately here. And basically this layer defines the total keep out area for the resistor. It includes the body, pads, and extra clearance spacing from if you have two resistors. So I will go to mechanical 13 and shift S. So basically it's this layer, and then I will go here and change this layer to the layer I just created here. So in the passive component is not really useful a lot. It's useful if you solder by hand. So the reason of this layer, so it's over here. Let me just copy this, all of it, Control C and Control V. And this layer, the courtyard. So if you have two resistors, for example, and you want to place them so close like this from each other, Altium can show you warning. Depends on the design rules that it will tell you those two resistors are too close from each other, and it might be a problem. So it's very useful to, if you have like 5 resistors in on row, you need some spacing to put your solder based, and you need to solder this resistor and this resistor basically, and you need some spacing to do that, and that's why we use this layer. So let me remove this. I will just give you a small example about this layer when it should, it's really useful. So if I have here 3D, I have this module. So it also, you can see the bats is here, and then we still have a body as well. So the bats basically here under the module. So if I don't have this layer, I might bring those capacitor or resistor very close. But then this layer here, which is Control S, this layer here, the courtyard layer, it will actually show me that I should not go more close. So I can go a little bit closer here, but I have to respect this line and don't go above it. So that's when it's really useful, especially if the bats are under the module, which you cannot really see it. Let's back to our PCB here. Shift S to see all layers, and let's save it. Then the last layer I want to add is the center layer. Sorry, I should remove. Here we added. So component center, and that's basically the center of your PCB. So I will just select this. Sorry, the center of your resistor. I will send it to component center and then save. So why I need this center? So if I go here again, that's better to see. You can see here I have some capacitor resistors, and sometime you will be confused, like, is this and this are the resistor or the capacitor, or is this and this the resistor or capacitor, especially when you place it next to each other. So if I have this center here, then I will know immediately my component here, it has pin 1 here and pin 2 here, and it's this one. It's also not something it will be printed or the manufacturer need, but then it's more for you. Then Control S. So now I have all the layers I needed for my footprint. So the last thing, I need to add this to my schematic here. Otherwise, there is no connection between them. So if I go back to my schematic here, then add footprint. So you can see here, there's no footprint. So library not found. And then add footprint, then browse. And this is basically my library. And I want to add this to this symbol over here. Then OK, OK. And now we have it here. Then Control S. So let's back to the project. Let's create just a new project just to test our library. Just create. And then add to the project schematic. Control S. Then add to the project PCB. Control S. So here if we go components, and then if we go here, you can see I cannot see the library I just created. And to make it visible all the time, you go here and then install. Then my library is here. I select those both and then open. Now it's installed. Then cancel. And if I go here, I select it, then I can see this is the resistor I created. So I place it here. Then I go here, properties. And then let's say 1 kilo ohm and R1. Then I go to design, update, validate change, execute change. And then I can see the resistor I just created is over here. And then if I press 3, I can see it has a 3D module as well. So that's the first method how to create your library. Then if you want to add another component to your library, let me close this. We don't need it anymore. It was just for testing. Don't save. And then library. So here you can see I just have a resistor. So let's do a capacitor, for example. So new components. Then cap. Let's say we want to do 0603 now. Then I will just copy this to reuse it here. So cap 0603. Then I put here comment, and then I do C question mark. Then I do exactly the same. So this is pin 1. Be sure it's 100. So now I have it on 50. So 100. Then tab. Then I press 1. So let me bring it here. So now I change it to 50 and let me draw the line. So you can also press P and L to draw the line. I will draw it like this. Then right click, left click, left click, left click, left click, then right click. So now I draw my capacitor 0603 and then save. Then let me hide these parameters. Of course, also you can add all the parameters we just did here. So all these parameters you can also add it here. I will not add it. You know how to do it now. So now let's go and make the layout. So tools, IPC, next, next, and here we need a chip capacitor. You can see here it showed me polarity. So in this capacitor, I don't have any polarity, but if you have a polarity capacitor, you can specify pin 1 or pin 2, which one and 2, which one is the plus and which one is the minus. Then I need those number for 0603. Let me get the data sheet. So you can use this data sheet for capacitors. If we go down, so basically we have to put 0603, so we have to put all these numbers again. I will do that and back to you. So I just put all the parameters for C0603 here using this table. Remember, this is the data sheet. I will also put it in the materials. Then we go next, 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 next. So it show me the X and Y for the paths. Next, next. Then I call it cap 0603. I save it on the same library. Next and finish. So here is our capacitor. Then we press 3. You can see it is a really nice one. So I don't need to add anything. I have already nice spacing here. So I just suggest to change those colors with something you are familiar with or the rest of your library. And let me just shift this. Yeah. Then I can see I don't have to add all those again and again. I have already the top. So shift S. This is a 3D module. Top assembly, top layers. So we can see here we don't have top over layer. That's also you have to add as we did before. Or you can simply also draw a line actually. So you have to be on the right layer, so top over layer, and then you can draw just a line like this. Yeah, and then you can just fix it. So you can draw a line, then it will be on your top overlayer, or you do the same what we did before. We just copy and then paste. So the only thing I need to change here is the solder rule, which is 0.05, if you remember. Then manual 0.05. Control S, and now we have our capacitor here. So you should do it correctly from the beginning. I suggest to change the color. You can, if you don't want to change the color, you can also just like double click here and change this to like, for example, 2 and then 8. So it's telling me there is 2 and 8. So you have to, if there is 2 and 8 exist already, then you can change it. Let me see how to, we don't need this. Let's see. So it's not available. M2 already in use. So it's here M2, then I call it M13, the assembly. And then this is M10. Then we can see the layers already changed. So you can do this M2 now and M8. So you have to delete M8 here, name it M11. So I have, I can show you how. Let me bring this design. So here how I do it when I change, it doesn't matter which M, but I know for M2 it will be this color, for M8 it will be this color, or you can just, without changing M1 and M2, you can put different colors. And then you play here also with the color, so it will be green here and this color here. It's just the way how you want to see your layout, but for me, when I see a color like this, I already know it's assembly layer. When I see black, I already know it's a component center and so on. Top overlay, I always know this color is represent the top overlay. And let me close this. So after you finish this, of course, you do exactly the same. So you go here, add footprint, and then browse. And then you need to add the capacitor. Okay, then save. So now it will be in your library, resistor 0402 and capacitor 0603. Yeah, that's the first method, and thanks for watching.